Hi everyone, in this video we are going to take a couple of examples from the topic height and distance. So first we'll begin with a simple question. Here the question says, when observed from the top of a 2 meter high wall, the angle of elevation of the top of a nearby building is 60 degree. If the wall is 50 meter away from the building, what is the height of the building? So essentially we have to calculate the height of the building. So let's try to draw a diagram and let's see how that looks like. First, I'm going to draw a straight line to kind of indicate the horizontal line at the ground level. Let's suppose this blue line is our ground level horizontal line, and then I'm going to draw the 2 meter high wall here. So let's suppose that this is our 2 meter high wall, the little yellow vertical line there. And again, when we say wall or building or stuff like that, we have to assume that they are all vertical. That means they will be perpendicular to the ground level horizontal line. So these are all kind of vertical upright position and they make 90 degree angle with the horizontal line. That is a given assumption in this type of problems. Next, I'm going to draw a vertical line to denote the building. Let's suppose this red line is the building. We have to calculate the height of this building, but let's assume that this is the height of the building, the entire red line. And since the observation was done from the top of the little wall there, so I'm going to draw a horizontal line through the top of the wall. Let's assume this light green dotted line is the horizontal line through the top of the wall. And next, I'm going to draw the line of sight from the top of the wall to the top of the building. Let's suppose this pink dotted line is the line of sight from the top of the wall to the top of the building. And in this case, the angle of elevation has been provided as 60 degrees. So I have denoted there that that's the angle of elevation. And next, I'm going to assign an alphabetical name to each of the important points here. So let's suppose AB is the wall, PQ is the building, and BR is just a horizontal line through the top of the wall, and AP are the 2 points on the ground level horizontal line. A indicates the base of the wall and P indicates the base of the building. In the question, we have been provided with the information that the wall is only 2 meter high. So you can say AB will be 2 meter, and if you think about it, that 2 meter will also be equal to PR, because APRB is actually a rectangle, because AP and BR, they are both horizontal, that means they are parallel, and then AB and PR, they both are vertical, that means they are perpendicular to both of the horizontal lines. So APRB is nothing but a rectangle, so AB will be equal to PR, and that's exactly what I have noted there. And the other piece of information that has been provided is the distance between the wall and the building, which has been provided as 50 meters. So essentially AP will be equal to 50 meter, and similarly, since APRB is a rectangle, BR will also be equal to AP, which is equal to 50 meter. And in this question, we have to calculate the length of PQ, which is essentially the height of the building. Now, one thing we can clearly see that PQ will be equal to the sum of PR and RQ. From here you can see, looks like we have a nice right triangle which is BRQ. If you think about the BRQ triangle, that's a right triangle because RQ is perpendicular on BR, so that will be a right triangle. And in that right triangle we know BR, which is actually equal to 50 meter, and also we know the angle QBR, which is 60 degree, that's the angle of elevation. So using these two information, we should be able to calculate the length of RQ. Now we have to find the length of RQ. We know BR and we know that angle right there, so I'm thinking we can use the tangent ratio here. So then we can say that tangent of 60 degree will be equal to QR over BR, that's the opposite over adjacent. And from here we can say that QR will be equal to BR times tangent of 60 degree. And if we plug in the value of BR, it will be equal to 50 times square root of 3. And the unit is meter in this question, so I have noted that as meter. 50 times square root of 3 meter. So now that we have been able to find out the length of QR or RQ, we should be able to calculate the length of PQ, because we already know the length of PR, which is 2 meter, and now we have been able to find the length of QR or RQ, that is 50 times square root of 3 meter. So what will be PQ then? Well, we know that PQ is equal to PR plus RQ. So now let's plug in the values here. In place of PR, we can write 2 meter, and in place of QR, we can write 50 times square root of 3 meter. And if we punch in these numbers in a calculator, we are going to get 88.6 meter. And that is our answer. So the height of the building seems to be 88.6 meter. If you look at the solution approach, this problem was really not a difficult problem. It was pretty easy. All we had to do is we had to use some basic trigonometric ratios to solve the problem. Next, we are going to work on another question which is slightly more difficult than this one. Let's have a look. The question says, from the top of a 100-meter high tower, Steve notices that Paul is walking towards the tower. When Paul was at point A on the ground, the angle of depression was 30 degree. That means the angle of depression from the top of the tower was 30 degree when Paul was at point A on the ground. When Paul was at point B, which is closer to the tower, the angle of depression was 60 degree. What is the distance between A and B? So we have been provided with two angles of depression, and also we have been provided with the height of the tower. We have to find out the distance between the 2 points A and B. So let's first draw the ground level horizontal line. Let's suppose this blue line is the ground level horizontal line, and let's suppose the yellow line there, which is PQ, that line is the tower, which is 100-meter high. And since we are talking about angle of depression, I need a horizontal line through the point Q. So I'm going to draw a horizontal line there through the point Q, which is the top of the tower. Let's suppose the dotted line is the horizontal line through the top of the tower. And next I'm going to show the line of sight for point A from the top of the tower. Let's suppose that's the dotted line there. And of course the angle of depression has been provided as 30 degree when Paul was at point A. So I have noted that the angle of depression there is 30 degree. Next I am going to do the same thing for the point B. Here I have drawn the line of sight for point B when observed from the top of the tower, and the angle of depression there is 60 degree. Now if you think about the two horizontal lines there, one is the ground level horizontal line and the other one is the horizontal line through the top of the tower. They both being horizontal, if you consider AQ to be a transversal, then this angle will also be equal to 30 degree, which kind of looks like the angle of elevation if you observe the top of the tower from the point A. And similarly this other angle here, that will also be equal to 60 degree. If you observe the top of the tower from the point B, then that will be like the angle of elevation. And again here BQ is being considered as a transversal between the two parallel lines. So those two angles, the alternate angles will be equal. So I have noted that as 60 degree. Since the height of the tower has been provided as 100 meter, I have made a note there that the PQ length is actually 100 meter. That's the height of the tower. Now if you carefully look at the diagram, you will see that we have two nice right triangles. One of them is APQ and the other one is BPQ. Those are two right triangles because PQ is perpendicular to AP. This is a straight upright tower. It cannot be tilted or inclined. So that is perpendicular to AP. Now we are going to use the tangent ratio here to establish some relationship, because ultimately we have to calculate the length of AB. So let me make a note of that here. We have to find the distance between the 2 points A and B. Now first I am going to do the tangent of 60 degree from the right triangle BPQ. It can be written as the ratio of PQ over BP, which is opposite over adjacent. And from here we can say then BP will be equal to PQ over tangent of 60 degree. And that can be written as PQ times cotangent of 60 degree. And we know that PQ is equal to 100 meter. So we can say this is 100 times cotangent of 60 degree. Next I am going to take tangent of 30 degree using the right triangle APQ. So in the triangle, tangent of 30 degree can be written as PQ over AP, and from here we can say that AP will be equal to PQ over tangent of 30 degree, which can be written as PQ times cotangent of 30 degree. And we know that length of PQ is 100 meters, so this can be written as 100 times cotangent of 30 degree. Now if you think about AP is nothing but the sum of AB and BP. We have to find the length of AB, right? We have to find the distance between the 2 points A and B. So we have to somehow find out the length of AB. So in place of AP, I am going to write AB plus BP. So AB plus BP will be equal to 100 times cotangent of 30 degree. And next, what I am going to do, I am going to plug in the value of BP, because we have already found the value of BP, which looks like 100 times cotangent of 60 degree. So I am going to use that value right here. So from here we can say that AB plus 100 times cotangent of 60 degree will be equal to 100 times cotangent of 30 degree. And from here we can easily find the length of AB. So AB will be equal to 100 times cotangent of 30 degree minus 100 times cotangent of 60 degree. And if you plug in these numbers in a calculator, the value will be like this. It will be equal to 115.47. And in this case, the unit of distance is meter in this question. So that will be 115.47 meter. And that is our answer. This brings us to the end of this video. In the next video, we are going to solve a couple more interesting problems. And as we progress, I'll try to increase the difficulty level a little bit. So in the next video, we'll solve 2 more interesting problems on height and distance. Hope everything made sense here. Thank you for watching. See you in the next video.